Hey folks, welcome to my channel number 10. So we have the problem on our screen. Show that the following functions are not differentiable at the indicated value of x. F of x equals minus x plus 2 for x lesser than or equal to 2, 2x minus 4 for x greater than 2, and we've been asked to show that the function is not differentiable at x equals 2, right? So as we see from the problem, the function f of x undergoes a transformation at 2, right? For values lesser than or equal to 2, it takes minus x plus 2, and for values greater than 2, it takes 2x minus 4. So for differentiability, like we have solved in our previous videos, we will have to establish what is our LHD and RHD, right? So let's write down our RHD first. So this is our RHD, which is called the right hand derivative f dashed of x naught plus, where x naught is the point at which you are examining the differentiability. Limit h tending to 0, f of x naught plus h minus f of x naught divided by h, right? And what is our x naught in this case? Our x naught is 2, right? And so wherever I have x naught, I'm going to replace it by a 2 and then go ahead and calculate the limit for this particular expression what we get on our screen, right? F of 2 plus h minus f of 2 divided by h, right? So let's look at the first part of the numerator, which is f of 2 plus h. And what does that mean? X takes a value which is greater than 2 by an infinitesimal h, where h tending to 0, right? So x is greater than 2 by an infinitesimal h means we will have to go ahead and apply this function, which I'm going to highlight in yellow, for f of 2 plus h, right? So let's write that. What is our f of 2 plus h? F of 2 plus h is 2x minus 4, where I will substitute my x by 2 plus h, right? That's my f of 2 plus h. And let's come to the second part of the numerator, which is my f of 2. My f of 2 is nothing but what is my f of x when x equals 2, right? And we know that when x is lesser than or equal to 2, we see that the function takes a value minus x plus 2, right? So I'm highlighting that now in yellow. And what is my minus x plus 2 when x equals 2? It is nothing but it is minus 2 plus 2, right? So which means it is a 0, right? And then I have my denominator still, which is a h. And so I'm gonna further simplify this. So I have got it as 4 plus 2h minus 4, and then my minus 2 plus 2 gets cancelled out, and then I'm left with a h, right? So I'm left with 4 plus 2h minus 4 divided by h. Again, my 4 and 4 can be cancelled out, which means I'm left with 2h by h, which is equal to 2. So my RHD is finite, it exists, the value of it is equal to 2. Now, for further establishing differentiability, we will have to go ahead and calculate our left hand derivative, right? So there we have the left hand derivative on our screen. LHD equals f dashed of x naught minus equals limit h tending to 0 f of x naught minus h minus f of x naught divided by minus h, right? And what is my x naught? The point at which I'm examining my differentiability. So I can go ahead and substitute it as 2 because that point where we are going to study the differentiability is 2, right? So now we have our LHD equals limit h tending to 0 f of 2 minus h minus f of 2 divided by minus h, right? And what is our f of 2 minus h? It is the value of the function f of x when x takes a value which is lesser than 2 by an infinitesimal h tending to 0, right? So in that case, which function we will have to consider? We will have to consider the function when x is lesser than or equal to 2, right? So I'm going to just change the color now. I'm going to highlight it as green. So we have x to be replaced by 2 minus h in the expression minus x plus 2, right? So I'm going to write that now as a first part of the numerator, minus of x. And what is my x now? Minus of 2 minus x h plus 2. And then what is my minus 2? My minus 2 does not change from what we calculated in our RHT. It is 0, right? Because it takes minus x plus 2 for x equal to 2 as well, and therefore when we substitute x equals 2 in the expression minus x plus 2, all that we get is 0, right? So I can comfortably write this as 0, and then I have a minus h in the bottom. So now I can further expand this minus 2 plus h plus 2, and then I have a minus h in the denominator, right? So which means my 2 and 2 gets cancelled, and I'm left with a h by minus h, which is nothing but minus 1, right? So so we can conclude that my LHD also exists, but it is equal to minus 1, right? So for differentiability of a function at x equals x naught, we know that my RHD, which is my f dashed of x naught plus, has to be finite, condition 1 met. My LHD has to be finite. In this case, LHD is minus 1, which is also met. But my LHD equal to RHD has to be my third condition, which is to be met for differentiability, right? And is that met? The answer is no. Why is that? Because my LHD equals minus 1, my RHD equals 2. My LHD not equals RHD, and therefore function is not differentiable at x equals 2, right? So that's how we go about solving these problems. I hope you found this content useful. Please do subscribe to my channel and support. Thank you.